talking about continuous compounding or continuous decay. So you've got another formula that you need to memorize. You learned it last year, and that was A equals PE to the RC. So we call that PERC. So yesterday I thought I gave you this equation, but I was telling Mrs. Farnhorst I have 3 classes, all of my classes I'm teaching logarithms. In the 9th grade and the 10th grade, so I'm getting sometimes a little confused as to exactly what I taught what class. Alright, so continuous compounding, this is your formula. This is your beginning amount. This is your rate as a decimal. And this is your time. Alright, so let's maybe do a little bit of a review. If I have a growth or a decay, if it just says growth or decay, what's your formula? Yeah, what's your basic growth or decay formula?
N to 0 times 1 plus or minus R.
Yes. That's your basic growth and decay. What happens if I say you're compounding it? You're compounding it like monthly or quarterly or daily or annually, but not continuously.
N to 0, 1 times R over T.
R over N to the NT. Okay, where N is how it's being compounded. 4 times means quarterly, twice means semi-annually. Alright, so there's the first one. Compounding is usually like quarterly or annually. It won't be a decay problem, it'll strictly be a growth problem. Alright, and then this continuous compounding or decay, well, that's going to be dealing with PERC. And you've seen PERC before. Haven't you done this in your chemistry class or physics class? Have you? PERC? P-E-R-C? Yeah. So you haven't done them in your science classes? No? Alright, so let's say you were left with an inheritance of $50,000. What average annual investment rate would be necessary for you to accumulate $2 million at retirement in 45 years? Alright, it's continuous. So we're going to say A equals PE to the RT. What am I looking for in this problem? I'm looking for my R, my rate, which is up in the exponent, right? Okay. So, what is my P? $50,000. E, my R is my unknown. What is my T? 45. And what am I going to set this equal to? $2 million. Comfortably retire. Okay. Alright, so if I got to get to my exponent, I need to move the 50,000. Wouldn't you agree? How would I do that? Alright, so E is going to equal, I'm going to lose 4 zeros, 1, 2, 3, 4, and that means 200 divided by 5 is 40. So E to the 45R is equal to 40. Alright, look at your calculator. Alright, look over here on your E to the X button. What's the inverse of E to the X? ln. It's the natural log. Those two always go hand in hand. Okay? So remember, whenever I'm trying to get to my exponent, I'm going to have to rewrite it as a logarithmic. But what I need to use is ln, not log. So when I rewrite this in the logarithmic form, we're going to say the ln, what's your base? What's your base? What's your base? E. E. Your base is what has the exponent, right? What am I going to put next to the ln E? So what am I going to put it equal to? 45R. Okay, so on your calculator, figure out what the ln, and it's an understood base of E. That's the only base that ln will have. Generally, you do not write it. Just like when I see log, the understood base is 10. So ln of 40 is this, correct? How do I get to my rate? 5 .08 who? More?
Well, yeah, there's 0.0819.
Okay. So that's my rate, but I need it, do I give it here as a decimal? Or do I need it if I'm asking for a rate? It needs to be a new cent. So that means I need to be accumulating 8.2%. Does that make sense? Put it away for 45 years, it guaranteed 8.2%, and you'll have $2 million. All right, convert log base 6 of 291 to natural log and evaluate. This is just a change of base formula, and all they're saying is instead of using LOG base 10, use LN base E. So if I take the LN of 291 and I divide it by the LN of 6, what do I get? .166, exactly. All right, here's an interesting thing. Take the log of 291 and divide it by the log of 6. What do I get? See, the interesting thing with log is that if I take the log of the number and the base, and it doesn't matter if it's log base 10 or natural log, it makes the playing field the same. And it puts everything in the same kind of terms, either natural log form or in base 10 form. So you'll get the same answer when you do change of base if you use natural log or if you use base 10 log. Okay. All right. So here, solve. 7.2 is equal to negative 288, 28.8 ln of x. All today's lesson is doing is having you work with natural logs instead of base 10 logs. You're going to follow the same steps that you did yesterday. So if I need to solve for the ln of x, I'm going to want to isolate that section, correct? Which means what do I need to remove? 5. So 7.2 divided by negative 28.8 is going to equal the ln of x. So 7.2 divided by 28.8 is negative who? And so how do I get to x?
E to the negative 0.25.
Exactly, you've got to rewrite it. If this is in logarithmic form, and I need to get to the argument, I have to rewrite it as an exponential. So what is e to the negative 0.25? And if I had time on a test, how would I make sure that that answer is accurate? Okay, so do it. Hit negative 28.8 ln of 0.778. Do I get it right? Will it be exactly the same value? Because we've done a rounding, correct? All right, it says solve using natural logs versus logs, LOG. So instead of logging LOG both sides, I natural log both sides, correct? So I'll do the ln of 3, I'll put the 2x out front, and I'll say I'll put the x minus 1 out front, and I'll take the ln of 7. So what would I do now? Which one? Okay, doesn't matter, right? It really doesn't matter. We just need to move one log to one side and then divide by the x minus 1 from the other. And so ln of 7 divided by ln of 3 is what? 1.771. That's all I got. Do you all get that too? So we're using our calculators correctly? Put this over 1, cross multiply. 1.771x minus 1.771 equals 2x. So that means 1.771 is equal to 0.229x. Divide now by 0.229. And what do I get for x? I got negative.
Oh, not minus.
Are we good? Making some? Alright, do I need to do another one of these, or are you okay on these now? Negative, no? Yeah. Oh. Negative 7.737. Take it out to at least 2 to 3 places.
Okay.
So do you want me to do this one again, or are you okay on this? Okay, I'll do it if anybody wants to. Alright, uranium is a natural occurring element. The most prevalent is uranium-238. Alright, I got this actually off of the uranium website.
On test, would you say to use these or to use natural or log?
I will tell you you have to use, but in word problems you'll have to figure them out. But for example, in these ones, if I say, I'll say use natural logs. But if I say nothing, then you have to know which one to use.
You can just use either one.
In these kind of problems, you really can. Okay. Alright, so uranium is a natural occurring element. The most prevalent is 238, which has a half-life. Half-life. Anybody know what half-life means?
It's like half of it and then half of that half.
Right, so if I start with 1,000 grams, if my half-life means it takes 4.6 billion years for me to have half the amount that I started with. That's why all of this radioactive material, you have to be really careful with, because it doesn't dispose of easily. It takes a long time for it to disappear, basically, or decay. All right. Uranium-235 takes 704 million years to get to half of the amount, and uranium-234 has a half-life only of 245,000 years. Okay. Carbon dating. You know how when you figure out how old something is, they can work backwards. If they know how much carbon is left in the material, they know what the half-life of carbon is, and that's how they work backwards to figure out how old whatever artifact is that they found is. Alright, so let's say you have 3 grams of uranium-234. At what rate does it decay so that you'll end up with 1.5 kilograms? Alright, so that means I start with this amount, and I want to use first, because it's continuously decaying. If I start with 3 kilograms, I'm looking for my rate, and what is my time going to be? 245,000 years. T, right? 245,000 years. Hold up the zero. And if it's a half-life, then what am I going to have over here? 1.5, right? If I start with 3 kilograms, I'm going to end with 1.5. All right, does that make sense? Oh yeah. Maybe that's why I have a problem with this problem. Your rate would be a half. All right. That problem didn't work out real well, did it? I was trying to figure out how to work with half-life, but okay. Yes. So we'll skip that problem. All right, moving on. I think I gave you a half-life problem in this book. We'll move on. Let me think about it. Okay, next one. Atmospheric pressure varies with the altitude above the surface. Meteorologists have determined that for altitudes up to 10 kilometers, the pressure P in millimeters of mercury is given by C equals 760. Anyway, A is the altitude. What is the atmospheric pressure at 3.3 kilometers? All right. So what does 3.3 represent? Is it your A or your P? What is it? It's your A. It's your altitude because it's in kilometers. Look at your units, correct? All right, so this is a plug and chug. 760 e to the negative 0.125 times 3.3. All right, what'd you get on that one?
I plugged my in calculator and it says false.
False. All right, try it again. I got this to work right. 503.115. I got about 503 millimeters of mercury. Got it to work now? Okay. All right, at what altitude will the atmospheric pressure be 450 millimeters of mercury? So now what does the 450 represent? That's your peak, correct? So 450 is equal to 760 e to the negative 0.125 a. All right, let's figure that one out. Well, it's up in your exponent, right? So what do we do when we've got a problem that has an x in the exponent? You're going to have to. So you're going to have to isolate it though. So move the 760 and then rewrite it. I would, yes, I would. And I got 0.5921 is equal to e to the negative 0.125. Is that what y'all got? So that's right. And you take the ln. My work right? Mario? Is that what you got?
I got 4.19 at 4 point. I mean, I got the point before the 4.
You got the point before the 4? The ln of 0.5921. And then I'm going to divide it by negative 0.125. I think it's right, isn't it?
Yeah.
Okay. All right, are we good? So this is the last section. We've got a test coming up. We'll do review sheet. It's going to be a pretty long review sheet. Starting, do I see you Monday? Nope. Okay. I would.
The 9.1 and 2.
Yes. And what else are you going to have on there? Trig stuff. Yes, you are.